Hey Brian, hey Joseph, and hey Meme Machine Rex. Just do it! Yesterday you said tomorrow. Hey Thunder, Wombologist. The study of Wombo? I Wombo, you Wombo, he, she, me, Wombo? Wombology? The study of Wombo? It's 3rd grade, Thunder. Nah, it's a SpongeBob reference. It doesn't mean anything. Do the math. 1 + 1 = question mark. It has to take me at least 5 steps to solve. Or else I only get partial credit. Okay, you know what? 5 steps, easy. All right. 1 + 1. Well, we know that 1 is equal to 1 in base 2, and we know that 1 is equal to 1 in base 2, and we also know that 1 in base 2 is equal to 1 in base 3, and we know that 1 in base 2 is also equal to 1 in base 3, and we also know that 1 in base 3 is equal to 1 in base 4. What is this, 1, 2, 3, 4, 5? And we also know it's equal to 2. There's your 5 steps. And you are what? For the 1,000 bits, thank you so much. The screaming husky. You don't think the husky agrees? I think the husky does that to everything. I think a pin drops and the husky does that. What am I doing? I'm probably not gonna do E&M right off the bat, but like, I just want to like talk about it because like, we're working on chapter 5, and it introduces magnetism, and it explains it as a consequence of special relativity. And I have not studied relativity in my life, and it's kind of crazy. We chill out, pause all my notes and chill. I think I'm going to do Penn Center's complex variables final. I only got halfway done with it on Tuesday. But like, there's this like, so if you have, like this F and F prime are 2 different frames of reference, and they're moving away from each other. An observer in frame F would perceive an observer in frame F prime as moving away. But an observer in F prime would think that it's actually F that's moving away in the opposite direction. And when you have a situation like this, if someone, what was it? If you're holding a rod parallel to the direction of movement, someone over in the other frame is going to perceive that rod as being shorter. But if the person over in F prime rotates the rod so it's perpendicular, everything is fine again, and that's freaking crazy. It's called the Lorentz contraction. And like, I assume you need a pretty big rod to see a significant difference, or maybe a very fast velocity. Only people with big rods are going to see the difference, is what I'm trying to say. But that's still, it's just weird. Like, why? Super Lorentz factor, yeah. And so I think in this formula, xb and xa and x prime b and x prime a are either like the coordinates of either end of the rod in each frame of reference. So the distance from it in one frame is equal to the distance in another frame, but divided by this gamma factor. And gamma depends on the velocity. It basically, more or less, it scales with the velocity. Don 3 inches is a big rod, right? It's a huge rod, Thunder. I think 3 inches is the biggest rod known to mankind. Do you have to do anything with relativity for the A levels, Thunder? If you do, that's kind of crazy. We do special. Oh, okay. Not like that. Okay. And so, okay, you're doing the A level further math, and that's to like that's literally just like to get into to university. Like you're doing this before you're even a university student. Oh, this is a Penn Center's complex variables thing. Or are you saying that Mobius is what you're? Wow, that's crazy that you're doing all that before being in university. Yeah, like differential equations. I didn't take until my second year of university. I did take calculus in high school in 12th grade, but that's like an AP class that most students don't do. Like it definitely wasn't normal. Like it's specifically a university level class that you can take early in high school. Differential thing was the last part. Physics looks like a living nightmare. On one hand, it kind of is a nightmare. On the other hand, there's some cool things in physics. That's from the E&M that I've been doing. Just learn to. That's kind of what I did when I was learning physics, and I hated it. But like circuits and oh yeah, that's fair with circuits. Those are like the electrostatics that we've been doing the first like 3 chapters. You can use multivariable calculus to kind of figure out the why, and you don't have to accept things as much. For circuits, I mean, we're still like learning the why of things, but it's definitely like a bit of a jump to go from one to the other. Hey, Stooky. Good morning. Scare me with all this relativity talk. It's kind of cool though. It's really weird, but it's kind of cool. Oh, the figures represent. I was literally wondering to myself last night why one of these is contracted in part A and then the other one is contracted in part B, and that's because of the Lorentz contraction. They're actually showing that in the figure, I think. In part A, we're pretending we're an F. In part B, we're pretending an F prime. Y implies intelligent design. We live in a no-Y world. Well, that's a different sense of why. I think Thunder is talking about like the idea of like building up things from axioms. Whatever the proper way of phrasing that is. And maybe next you're asking like why those axioms are there in the first place, I think. But I don't know, I would like to figure out what's up with Penn Center's final for the last stream I did these two. They weren't so bad. These two though, I need to look at the notes for this Mobius stuff. Hey, Jed. Oh my. So wait, I think, okay, yeah, I remember I did do part A on Tuesday though, or it's this much of part A. The eigenvalues and eigenvectors were kind of annoying because it was some rational number plus an irrational number. I'm just gonna use Wolfram to get them again because I'm too lazy to do it by hand. So what you do is you can take the coefficients of these and put them into a matrix. So 1, 1, 2, 3. 1, 1, 2, 3. Oh, right, but there's kind of a specific point, I think, that Penn is probably doing here, which is you get unit circle values for the eigenvectors. And so I think the idea is that under this Mobius transform, I don't quite know the right phrasing for it, but any complex number that's on like the ray generated by these eigenvectors stay the same, I think is the idea. Was there an example? Okay, yeah. So I want to see what the class notes are for this number 2 question. Let me see if I can dig through Penn Center's Discord and find them, if they're still there. I think Penn Center said he's going to delete the thing soon. Oh, hey, good, they're still there. Over the next week, and next week is, well, that was 3 days ago. They should still be here until I'm through with this. Explain, right, that's a B. Okay, so I want something just after that image. No. Is it this one? It's a big old image right there. Oh, it has about 2 pixels total. Dang it. It's not ideal. Try. Oh wait, it's because of the way that I did it. That's weird. I haven't had that issue before with Discord images. It's fine though. Now I know. So it should be the very next image. No? Turn. Oh, wait. We might want that. We almost definitely want that. And then we almost definitely want this. Okay, nice. Okay, so, oh god, this scrolling goes quick. So in this example, diagonal vectors were I1 and minus I1. Hey, Cold Gold. How's it going? Matrices and complex numbers, oh, do not say that around Penn Center. That's like his favorite thing. I guess it was at a pretty like a terrible time for you, but he was just doing a class where he taught all this stuff. And I didn't directly participate in the class, but I've been kind of loosely following along. I would like to learn this stuff a bit more in depth at some point. What's the idea behind the Mobius transform? I kind of forget. What does it let you do? Because there's some kind of like mind-blowing thing that they did with this when you do merge complex variables in linear algebra. I forget why they're neat though. Once analysis is very cool. Yeah, I mean, I hardly know anything about it, but I'm interested to learn more. You know what a Mobius strip is? That's about it. I don't know if it's related or not, but oh, this is probably the cool thing. Hey, Aditya. Yeah, welcome back. Okay, I was just in week 6, class 11, so let's look at week 6, class 12. Oh dang, that one doesn't have the images for that last one. All right, thanks for the lurk, Thunder. Where were the notes for number 5, or did they... Huh. Spencer maybe skipping around, maybe just never got to that one. It's also possible, I guess. That's not it. Get... okay, I'm not seeing it. So, where are the fixed points of M of Z? I saw somewhere in these notes we can take M of Z equal to Z here. But I assume there's going to be something... This seems like it should be related to the eigenvalues and eigenvectors. I don't imagine we have to actually solve it with solve a quadratic with those coefficients. I feel like we should... If we did the work in this part, I feel like that should give us a hint for what the fixed points are. And that's the thing that I want to find. This is Penn Center's final exam. So I think the due date is already like long past anyway. I'm just doing it for fun. And even then he said it's fine to like solve it on stream if you want. So yeah, the deadline was August 30th for the students who were actually taking the class, but it was just the one that Penn Center made for his complex variables class. So I'm just doing because I want to see how it works. It's just that this Mobius transformation stuff, I didn't pay as much attention as I should have when the class actually happened. Yeah, Aditya, I remember you. So I'm trying to remember, like, there's got to be. Oh yeah, please feel free to ask it, Joseph. This is just filler. Homogeneous coordinates. Those are described. Right here. I think these play some role in the Mobius transform stuff. I don't remember exactly what. If you put it in the Discord, Joseph, just let me know in chat when you post it. So it's a way of representing complex numbers as a vector, I guess. But not, I guess, a vector in the way that you would think, with a real part and imaginary part, as an entire complex number and scaling factor, I guess. According to this, they are the complex ratio corresponding to a given z. Yeah, I think there's a certain, like, freedom of choice with, like, your choice of z2, I think. Like, for the same complex number, there's infinitely many representations in homogeneous coordinates. I thought I saw a flash on screen for a second that AB is an eigenvector of M if and only if A over B is a fixed point of M. Oh, that would be a helpful fact. Where would that have been? Oh, ha! Great catch, Stoogie. I wonder why it's only a single fixed point. Or maybe, oh, this is homogeneous coordinates, though. I wonder if there's... I imagine it would be all complex numbers with the same argument would be fixed under a transform like this. Rather than a single point. That seems kind of random to me. It's just like two single points rather than two rays. Does this... That was part C. Oh no. I have parts A and B, but not C. Oh, here's C. Oh, okay, let's look at Joseph's question first, though. How do you approach this? I'm currently in the process of just showing additive identities, or all the field axioms, Lamau, then just showing that if A, B, C belong to F, blah, 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 using B and C satisfies it as well. If A, B, C must be equal to, example, the inverse of A. Prompt, using nothing but the field axioms, prove the additive inverse of an element A belongs to F is unique. Oh, no, that's completely fine, Joseph. I just want to make sure I didn't, like, miss it if you put it in Discord. Chat is completely fine, too, though. Showing if A, B, C belong to F, blah, blah, using B and C satisfies it as well. B and C are satisfying what? That blah, blah might be important for what I'm reading? Oh, wait, it might, maybe I know it all from this. We would let, if we want to prove the inverse, the additive inverse is unique, then I'm just kind of spitballing. I think what you would do is let B and C be the additive inverse of A. So A plus B equals 0 and A plus C equals 0. And I hope you're, if we're allowed to do algebraic manipulations here, what I want to do is say, then, like, basically subtract the B to the other side, A equals minus B, and A equals minus C. There's another, like, I might say, like, hence, or I'm going to say so again, because I just have a problem with hence. But if A equals minus B and A equals minus C, then minus B equals minus C, and B equals C. So I'm using the word so way too many times, but so the additive inverse is unique. I think this is the idea of how you would prove something like that. I combine my U and my E right there because it's much more convenient than writing out 2 letters. Yeah, that's basically the same idea as what I put there, Joseph. How you usually prove uniqueness for something like this is you just let there be 2 possible solutions and show that those 2 solutions are really the same thing. That's the normal kind of structure for how you prove uniqueness in this context. Actually, I think really in almost any context with proving something is unique. You could also phrase it as like a proof by contradiction. I think some professors don't like that. But you could have also said, like, you know, let B and C be 2 distinct additive inverses of A. And then we could do kind of the same argument to find that B equals C, which means they aren't distinct at all. So that would be a contradiction. But I think it's considered good practice to do a direct proof like this. This is an additive inverse GED specifically, so I don't think we have an issue with irrational numbers here. That'll be the inverse of, like, squaring. Well, A equals square root of 4, that only has one value, A equals 2. If A squared equals 4, then you do have 2 values. Yeah. And so, yeah, we don't need to bring, like, multiplication into the picture when we're talking about additive inverses. Jed is always ready to accept this once, yeah. Uh, but yeah, like doing these types of proofs always weird me out with how like I like how like the stuff, it feels like it should be obvious and we don't have to prove it, but you do technically have to prove it. So oh, I just noticed the glare from the light is kind of annoying me. I accidentally kicked my light, and so I had to reposition it, and I didn't check. Is that better? Not really. All right, fine, who cares? Gonna let it red. Can have a long bath now that I'm actually doing this one correctly, because the proofs I repeat one are so convoluted and stuff. Okay. A long bath? I hope you enjoy your bath, I guess. I feel like baths can get a little gross. Unless you're already clean, I guess, but then what's the point of taking a bath? What about the absolute value of A equals N? We're only talking about additive inverses here, Jed. I don't think we need to bring any sort of like function in here. I don't think you're gonna break it with like introducing a function, because now we're not talking about just additive inverses. You don't okay, well, I haven't had a bathtub since I moved out of the house that I grew up in. Actually, have I? I technically have, but it's like I'm not gonna take a bath in a college apartment that never gets cleaned. But I'm not usually inclined to like take a bath, I guess. Just kind of chilling out in water, rather just lay in bed and chill out. B equals B plus 0 equals... Oh! Sip tea while in bath? I mean, yeah, you need something to do while you're in there. Yeah, that should work too, Jed. Because I'm never quite sure what we have. So like, I don't know if Joseph necessarily has the subtracting something to the other side yet with these. So that might be even like a safer way of proving it. Something like this in the workshop problem set. Yeah, that one's pretty hard to spot. I don't usually do questions like that, so it's not something that I'm used to. I guess it really is just a fixed point. That's kind of annoying. Okay, well, we can do, what are our eigenvectors? So, thankfully, Wolfram alpha gets 1 for the denominator for each of these. So our two fixed points are -1/2 plus root 3 over 2 and -1/2 minus root 3 over 2 are the fixed points there. So part B, construct f of z equals z, z1, 0, z2, where z1, z2 belong to C are the fixed points from part A. Now what the hell is f? Well, this looks like it might be... This looks like the same format, kind of. Oh, it probably is this. The cross ratio. Hmm. Let me see. Okay, there's an F right here. I saw the one pop up. I did look. It was I looked at the perfect time. Yeah. If you did that like a split second earlier, I was watching you read it. Yeah. Oh yeah, I guess that's the easy way. If I'm at the board, I can't check chat. Thank you though. Not sure. Oh yeah, I usually try to be lazy and not go to the board. Um, so that's fair. Oh, huh. What's M squiggle? Uh, it's just some other M. Had any good sink tacos lately? Dude, those tacos are kind of crazy. Oh God, I think the notes might not be as ideal because Penn Center was having the tech issues towards the end, wasn't he? Um, so I wonder if that's why the notes, why there's some like missing things. Let me see. What question is that one? No, I don't want that. We might just not have done 3 and 4 as a class. Oh wait, maybe. Oh, he only posted the VOD. All right, look. Let's see if we can find it in his VOD. It appears to be meanings turn out to be true. The empty set is an open set. Uh, yeah, I forget the justification for why, but there's weird stuff like that. That is definitely true. Okay, so this is, I think this will be the stuff that I need for this. Skip straight to the juicy part though. I don't need to know why, let's just know what. I should actually really go back and listen to this. I don't even slightly remember Penn Center doing this. I must have missed this. fixed points of z equals a and z equals b to f of a equals 0. What does this mean? Is this like a vector or? What actually is this? I feel like I need to actually just go back through and watch this VOD at some point. Yeah. I think it's gonna be too much for me to want to do on stream. More than I look at it. Can I figure out part 2? Probably not. All right. I think these questions are gonna have to wait for another day when I've actually studied more. Because I think I completely missed out on that class. I was probably playing video games or cooking or something. Cheap viewers. So maybe we'll do E&M instead. Pull a problem from somewhere here. We're definitely not going to have time to get to all the questions that I called out, so maybe let me get rid of a ping that I just got on Discord. Ugh. Ping me about something helpful, please, Stream Elements. Okay. 1, 2, 4. Okay, we ended with 10, 12, 14, 15, 17. Oh god, 4 stars. Take cover. 12, 14, 15. Which ones are interesting ones that I would definitely want to save? 13 or 12 and 15 I can probably isn't all that interesting. 17. This might be a differential equation one that I think I want to save. What else did I call out? 20, 24, 27. Isn't all that. Isn't probably worthy of being saved. 24, 27. Wait, 24, it's a 1 star. I think it's just a calculation. That's probably not all that interesting either. There wasn't really fun ones. I think we got to the most fun ones that I found. 36, 37, and 40 are the last ones that I called out. Oh, this one. Yeah, these two. We kind of already did this one, though, didn't we? How is this different from the spiral? We already did, yeah. Okay, that's a little. Okay, so the only one that I probably want to save for the group on Saturday is 17. Anything else? I'm just gonna look at the rest of my list. Actually, maybe we'll go to the second part. So 20. What was 20? We have 5 times 10 to the 16 doubly charged positive ions per cubic meter. Doubly charged positive ions. So they're 2e. All moving west with a speed of 10 to the 5th meters per second. In the same region, there are 10 to 17 electrons per cubic meter moving northeast with a speed of 10 to the 6th meters per second. Don't ask how we managed it. Fair. What are the magnitude and direction of J? So we have west and we have northeast, but these are west are positive ions, northeast are electrons. So I think we need to consider electrons moving northeast as equivalent to... Wait, these are positive ions, not protons. What does it mean to be doubly charged? Because can an ion have various amounts of charge? I assume doubly means it is 2e like I initially thought. Hey, Cook. Thank you for the help with that relativity one. I was getting really into the weeds of trying to like figure out if things are drawn to scale or not to make those axes work, and the way that you said it was just way simpler. The current... Wait, don't we need a dot product? NQU. Like, I was picturing this in my head. We need to draw a surface for things to go through. Yeah, like A dot U. Oh, there is... Why does the A dot go away? Oh, I is equal to A dot J. Oh. What was the question asking for? I or J? J. So do we not have to care about... I guess we're gonna need to break we're gonna need to break this one up into components. But I think we're otherwise fine. NQU. And U is velocity. Yeah. Okay. I think we know what we need to know. This one on the board. Oh, it's 420. I didn't even think about that. We gotta do 420. Okay, so doubly charged, I'm going to interpret doubly charged positive ions as a charge of 2e. So I don't know what else that could be. So moving west. I think we're going to define west as positive x. I guess we may as well make this positive y. So moving west, we have 10 to the 6 times 2e coulombs. Or is that coulombs? Probably. I don't know. Who cares? In moving northeast, we have 10 to the 17 times minus e coulombs. But I think we're going to be sneaky and consider negative charge moving northeast as positive charge moving southwest, because that'll make the calculations a little bit easier. Probably not actually all that necessary, but we can call that one J1, that one J2, vectors, and then take their sum to get the total J. All right, so J1 NQU. So N is 10 to the 6 doubly charged positive ions times Q is 2E, I'm calling it. I hope that's right. And that's it. Or wait, no. Their velocity, 10 to the 5th. And 0, oops, y component. J2 is 10 to the 17 times positive E times velocity. Oh wait, this one needs components. I don't know if my mic was picking up the siren there, but sorry about that. Speed of 10 to the 6 meters per second, but the portion of this that's in the positive x direction, as I've defined it, is cosine of 45 degrees. So the y component is going to be times sine of 45 degrees. Now we add up these two vectors for the entire j. So let's make Wolfram Alpha do that. Hey, Twist memes. Feel free to post it, yeah. And Ridhima, hey. Zero. 10 to the 6 times 2 times 10 to the 5 plus 10 to the 17 times 10 to the 6 times square root of 2 divided by 2. And this will be the exact same thing. It's sine and cosine equal at that angle. You want to give me the decimals, Wolfram? Or like scientific notation, maybe? No? You're cool? You don't feel like it? It's cool. I have ways of getting around this. All right, 7.1 times 10 to the 22 is j in the x direction. They want the magnitude in direction. So actually, the magnitude is going to be square root of this thing squared plus this thing squared. Hey, Sony? Give me the decimal, Wolfram. Wait. It is about 0.1 to 1,000 times the number of grains of sand on the Earth. I don't quite know what that means, to be honest. Factorize sine cubed of theta plus cosine cubed of theta. Hence, prove sine cubed plus cosine cubed over sine plus cosine plus sine plus cosine equals 1. Well... what's this? I assume we need this formula here. Yeah, the YouTube chat can be a little bit of a pain with that. I think I get the idea, though. I guess that works. Not the prettiest problem text I've had in my life. But I assume we're going to apply this formula to sine cubed plus cosine cubed and hope for something. Oh, this actually might not need too many steps. All right, so if we do the sum of two squares formula, it's sine of theta plus cosine theta times sine squared theta minus 2 sine theta cosine theta plus cosine squared theta. And what's the goal again? Interesting. So I think what they want us to do, they're asking us to prove something about sine cubed plus cosine cubed over sine plus cosine. So let's divide this over to the other side, I guess. And we do that sine squared plus cosine squared is equal to 1. That's a Pythagorean identity. So we can get a 1 on the right-hand side. And we're getting pretty close to the format they wanted in. I can also add this to the right hand or to the left-hand side. So let's do that. Is there maybe a typo in the problem? Because I think we just did it, except the text that you put, there wasn't a 2 there, but I think there should just be a 2 there. I don't imagine it's correct without that 2. See what Wolfram Alpha gets with us. It should find that it... Oh, what? Why is this not equal to 1? Did I make a mistake? Maybe I did make a mistake. If I take out the 2 here... Ooh, I made a mistake. I don't need the 2 in the factorization? Oh my god, Fenbox! I mentally inserted the 2 in there. Thank you. Alright, my bad. Twist memes. I just got the formula wrong for the sum of 2 cubes. This 2 should not be here. Other than that, I think the work is all right, though. So let me know if you have any questions about that. Inbox FTW, agree. Okay, you put a different... What is that supposed to be, twist memes? Factoring the top somehow? Oh, yeah, you can do that too. Oh. Yeah, I mean, I don't think you have to do what you just said. Like, you could factor this again and get a simplification, just get a 1 on the left-hand side, but we've already proven this entire thing equals 1, so I don't think we need to do anything more. Okay. No worries. Oh, you're talking about... Oh, I see. I did it in a different way. Okay, maybe now I understand what you're doing. You're talking about starting from the left side of what we want to prove and applying the factorization, which works too. I did a different direction. I'm not very good with coordinate geometry. I can try it. There's a lot of... I don't know any of the tricks when it comes to coordinate geometry though, so that's my warning. I'll wait to see what the question is. I'm gonna keep looking at this. And then we'll frame alpha. So the magnitude of this thing is basically 10 to the 23 of my J vector. Which 10 to the 23 always reminds me of Avogadro's number. But we don't have a 6, so it doesn't work. We do need the direction. So we need an arctan in our lives. And we expect the answer to be in quadrant 3. So maybe we actually want to give Wolfram tangent of x equals y over x. It's only really? Okay, I'll look at this more after. Vertices of two triangle ABC are those. Find slope of BC. Oh, yeah, we can do this. There might be, I mean, if there's a trick to do it quicker, I don't know it, but I don't think this is too hard to do with the normal ways that I know of. Solved it earlier, you can't get it now? Okay. No worries. Oh God. I don't think I'm gonna draw this, or at least not exactly. I'll draw an approximation. So 3/8, let's call it somewhere way up there. Minus 1, 2. Let's say it's somewhere right there. A, B, C is 6, -6. So call it somewhere around there. So I'm not drawing this exactly to scale, but just kind of approximate so we have an image to work with here. We want perpendicular to BC and passing through A. So the line that we want is something like that, if I actually had art skills. We know the equation of a line is y equals mx plus b. So the task is to figure out what m is, and the task to figure out what b is, and then we have our answer. So let's start with m, because if this line is perpendicular to BC, we can find out the slope of BC and then do the negative reciprocal to find the slope of the perpendicular line, which I think that's what the problem says to do explicitly. Yeah, find the slope of BC. So to find the slope of BC, so we do y1 minus y2 over x2 minus, wait, you have to have subscripts in the right order, but y1 minus y2 over x1 minus x2. Which one is 1, which one is 2 doesn't matter as long as you're consistent. So I'll take b as the first one. So 2 minus 1. C is -6 and +6. Yeah. So now we just do that math. 8 over -7. So I'll just put the negative in the middle because that's fine with fractions. All right, so that's the slope of BC. If we want the slope of like this m here, we make it we put another net. We flip. Sorry, we flip the sign and we flip the fraction. So since m is perpendicular, the negative turns positive, and 8/7 becomes 7/8. So now we know y equals 7/8x plus b. We just need to figure out what b is. And we can do that by plugging a point in that the line should pass through for x and y. And we were given that it passes through the point A. So let's do that. A is 3, 8. So x is 3, y is 8. Let's plug that in. Times 3 plus b. Now solve this for b. It's kind of annoying to solve for b, but we sure can. 21/8 plus b. Subtract the 21/8 over. Get a common denominator. So I'm going to multiply that by 8/8. So we get 64/8 minus 21/8 equals b. 64 minus 21 is 43. Weird number. Okay, so I say the answer should be, you know what b is now? Y equals 7/8x. That's not a 7. Plus 43/8. Oh my god. And sometimes they also prefer to have it, they want you to factor the denominator out if it's the same. Usually people don't care, but just in case, you may also see it in this format. They're completely the same thing. I personally like this format more, but they're both true and valid. So I hope that agrees with the answer that you got. I never heard of CSE, so I assume not. Why doesn't it just give me the arctangent? And why it shouldn't get two solutions, sure. Or is arctan different? I want it to be in the third quadrant. And I think it's giving me the answer in the first quadrant. So can I just take the negative of the... All right, fine. Let me... You have a weird request? What's that? Oh, shoot. I'm not showing my browser. 45 degrees. Oh, well, that's clean. What? I thought the, Huh. So it's 10 to the 23 and 45 degrees? But, like, from the... I guess... Oh, with the way I defined my coordinates, I guess it is. Yeah, okay. We are in quadrant 1. I just defined my coordinates, like, diagonally reflected. Okay, so magnitude I'm saying is 10 to the 23. Direction I'm saying is exactly south west. Can you adjust your accent? I'm Indian and I'm facing difficulty to understand your accent. Some ways are completely understandable. That's fair, and I appreciate you. I'm not gonna do an Indian accent because that can uh I'm not particularly good at it. I can try to speak slower though if that would help you. Uh but me trying to do an accent is not gonna work out too well. So, or I can try to write more things on the board rather than speaking. Do it. I don't know, Cook. I don't imagine me trying to do an Indian accent would actually be all that helpful. Question, mensuration? I don't know what that means. If you want, you can just put the question in there and I'll tell you if I can do it. I want to check my answer to this question. Oh, cylinders, cones, and spheres. Yeah, I should be able to help with that. Tell me what the question is. Ugh, everything is paywalled. Oh, here we go. Oh, this is a different question, though. Oh, of course. Brainly, would you paywall me? Oh, I'm gonna get paywalled. Yep. I guess I just have to assume that I did it right. All right, what was the next one that I said I wanted to do? 24. An ion in a liquid is so closely surrounded by neutral molecules that one can hardly speak of a free time between collisions. So to see what value of tau is implied by equation 4.23 if we take the observed conductivity of pure water. Oh, twist means I see your question. A hemispherical and a conical hull is scooped out of a solid wooden cylinder. Find the volume of the remaining solid when the measurements are. What would I call this? I didn't know what this would be called. I guess like solids or volumes or something like that when we're talking about getting the volume of three-dimensional objects. A spherical and a conical hull is scooped out of a solid wooden cylinder. Oh, I mean, I don't need that last sentence, do I? There we go. Hey, Joel. Okay, let me look up the relevant formulas. Cylinder volume. And hey, Keyvan. Pi r squared h. I feel like I knew that. Let's erase the board too while I'm at it. That's just integration. I feel like I should just be able to figure that out. Pi r squared h. What's up? Not much with me. How about you? The volume of a sphere is pi r cubed. And this implies the volume of the hemisphere is half of that. Good to hear. Wait, sorry, 4/3. 4/3. Something looked wrong to me about this. 2/3. Right? I'm gonna Google that too for the hemisphere. Yeah, okay. And then we also need the volume of a cone. Okay, 1/3 pi r squared h. That's right, it's 1/3 of a cylinder. Somehow. So what is that kind of cylinder? This is a weird. I wonder if I'm overthinking this. So that's our cylinder. The cylinder has height 7. Oh, do we know the radius of the cylinder? Oh, yes, we do. 3. Perfectly drawn. Okay, nice. Height. A hemispherical and conical hole is scooped out of a solid wooden cylinder. Height of the cone is 3. Okay, so everything else is kind of 3. So we have a hemispherical hole, radius 3, and a cone, radius 3, height 3. Now I'm overthinking. I think I know what answer they want, but I feel like this question is weird because like for the hemisphere, that's a flat surface, but the cone isn't flat. The cone goes like that. Like it's curved. So I assume they don't, it's almost like a football, but I assume they don't want us to care about that. Because I don't know how you deal with that, to be honest, and I don't think they're trying to ask that hard of a question. But the setup of the question feels a little bit weird, but I think what they want us to do is say the total volume is equal to the volume of the cylinder minus the volume of the hemisphere minus the volume of the cone. So we're taking the entire volume of what the cylinder would be without any holes, and we're subtracting out the cone and subtracting out the hemisphere. It's a 10th grade question. Okay, yeah. I won't overthink it. And we know what each of these three things are, so let's plug into the formula. So volume of the cylinder, pi times radius squared times 7 minus hemisphere 2/3 pi times the radius cubed minus volume of the cone 1/3 pi, radius is 3 squared, height is 3, and this entire thing is going to have units of cubic centimeters. From here, I will plug it into a calculator. Oh, actually, no, let's not do that yet. You could plug this into a calculator. They might want the exact answer, though. So let's actually work out what this math is going to be. So that's 9 times 7 is 63 pi. 3 partially cancels, so we have 3 squared times 2 is 18 pi. 3 cancels one of those 3, so we get 9. Now subtract the coefficients. 63 minus 18 is 45. 45 minus 9 is 36. Oops, pi. So if they want an exact answer, then it's 36 pi cubic centimeters. But whoa, Bob, how do you do that? What the heck? Go out and touch grass? Never. That's great. I've never seen that before. Your message is all like highlighted. Gonna study Julius Caesar, then just randomly crashed here. Oh, nice. It's 20 bits? Oh, well, thank you for the 20 bits. Okay, so I would say 36 pi cubic centimeters is a valid answer, and I also say 113, 0.1 cubic centimeters is a valid answer, or however many decimals you would round to. Why would I touch grass? That stuff is dangerous. Oh, you could do that too. 22/7. Grass, never heard of that either. Yeah, that's what I like to hear. But you have an idea? I need to do Discord profile picture. Okay. Scoop's taken from the top and bottom. Oh yeah, Lubird. That will be better. That would avoid the thing that I was saying. That's probably the more accurate drawing here. So what Lubert is saying is that the scoops are actually, like, the cone is down on the bottom side and the hemisphere is on the top. And that avoids the issue that I was saying. So that drawing makes a lot more sense to me. Draw Uncle Iroh. Oh. Okay. Let's get a reference picture. Wait. Okay. Uncle Iroh is one of the best characters in this. Use your Discord profile picture as a reference. Oh my god. Can I find it on Google? Teeth. This is a weird Google search. No, okay. Let me, you know what I can do? Take a screenshot of it, because I just want to show the stream what it's supposed to look like. Oh my god, what did I just do? I minimized my OBS, that's what I did. Another question from geometric progression? Yeah, sure. There we go, Bob. Thank you. That's a lot easier. That's what I'm supposed to draw. Quit The Last Airbender. You have exam 2 days later. I can multitask. I like to have a bit of fun. Start like putting your next question in there, but I want to draw this. It'll just be off to the side here. Wait, let me. We don't want to lose this beautiful reference picture. There we go. I've seen your I noticed you changed your Discord profile picture, and I was trying to figure out what it was, but it was so small. I was like, I can't tell. But that tracks. And actually, my black marker is out of ink, and I don't have more ink, so I'm gonna have to improvise on the color choice here. Huh. It's the top of his head. I feel like I'm already messing it up. Okay. How's his beard? His beard just kind of spikes out. See, he has the most amazing sideburns. And it just kind of connects at a point. There's a little ear in there. Top of his head is y equals minus 0.5x squared. Basically. And we'll mirror it on the right. We got a little goatee. I kind of, oh man, I meant to not do this entirely in blue, but get a little bit of orange, at least for a little gold thing in the top of his hair. Little man bun that he has. Okay. The nose, pretty huge. He's got a honker. Those are the eyebrows. Then the eyes. Is that how they... Not quite. He looks more angry in my thing. Whereas in that picture, he looks surprised. You need the eyebrow lines. The lines help make him look a little more surprised, I guess. Got in the class from the wait list. Oh, nice. Semi non-science class now. More cheat viewers. Double cheat viewers. Triple cheat viewers. What? That's a first. Quadruple cheat viewers. What? Oh my god, I'm being attacked. I've not had the quadruple cheat viewers. I've only had a double. Your math teacher has beef with you. Bro beats my ass every day. Oh, I hope that's not actually happening. DDoS from cheat viewer bots. Yeah. Oh yeah, I got in the class. Yeah, I read that. Looks like Sokka drawing. You made him look evil. Yeah, I did. Seems like O'Connor forgot to drink his tea. Yeah, drinking tea with fascinating strangers is one of the true delights. One of life's true delights. Dude, yeah, it's freaking Iroh. It's a semi because it's a science writing class. Okay, nice. Either way, I hope that oh, you can't really see his pupils. At least in the OBS preview, I can't really see his pupils. Make him a bit more defined. Okay. I should have copy pasted their message and added it as a banned phrase. I bet I still can. Let me... Oh, thank you, Jed. You are 5 steps ahead of me. Okay. Twist means if you have another question, feel free to drop it in chat. Otherwise, I'm just gonna keep doing some studying. Yeah, I assume they're doing that to get around the auto mod. Oh, you tested it too, Joseph? Nice. Yeah. It's funny, dude. It's like the bots think that one message isn't enough, so they have to put four in at the same time. Question is already in there? I saw you. Oh, okay. I'm sorry. Yeah, I missed that message. I thought it's blocked 7 times. Okay. Oh, you have to watch my stream more, Bob? That sounds like the worst. Yeah, I'm sorry I'm making you actually like watch the stream. It sounds terrible. In a geometric progression, the first term is 7, the last term is 448, and the sum is 889. Find the common ratio. Okay. I wonder if there's a trick. I'm gonna have to do some thinking. It's 889. Yeah, what's the formula for a partial sum? I only know the one for the infinite sum. Oh my god! The bots have it out for me. I won't ban that one yet because I want to get that special character in the block terms list too. Or Jet if you're able to. No, I'll do it after this question. A times r to the n minus 1. Okay. Like that. For A0, you have A0 times q to the n, and you have the sum formula. Thanks, Jed. Go part. I was invited. That's okay. Just stay at home, play some video games. There we go. That's the spirit. So yeah, we don't know the n. Isn't that the issue? So we know the sum is 889. We know the first term a is 7, but we're stuck with one equation and two unknowns, aren't we? Oh wait, no, you're okay. I see what you mean now. We also know the last term is 448 is equal to a, which is 7. 7 times r to the n. Because the last term is equal to the first term times r to however many terms you have. Okay. Oh, n minus 1? I was just about to wonder that. Yeah, I guess the first term is just 7, so it should be n minus 1. Head to bed after this? Okay. Twist memes. Sounds good. Using punctuated characters, you cast a wider net. Alright, sounds good, Jed. Depends which SN formula you use. Oh. But, well, crap. I'm just going to assume that I'm right, because I don't... Oh, wait. Because we need to plug into there, don't we? I think it should just be n. If I'm doing that one? Wait, it's correct. Do you say that before or after I erase the -1? What is 448 over 7? Does that go in evenly? 64? Okay. My sweet little Dawn. Some has one more. The potential? What? I stream to YouTube and Twitch memes. So the chat that's up there is the Twitch chat. I'm not allowed to show the YouTube chat, unfortunately, on screen. Oh, country. I'm in America. Okay, Bob, the thing you said with the potential, I don't know what that means. I should just figure this out, right? My gut is telling me it should just be n. We can always check our answer. Class members are to the end. Oh, really? They do have to be offset like that? Okay, fine. I'll make it n-1 then. All right, so we divide the 7 over to get 64. It's equal to r to the n-1. Wait, that's not good. No, it is good. We can multiply each side of this equation. So we have an r to the n here, but we're stuck with an r to the n-1 there. So I'm going to multiply each side of the equation through by r to get 64r equals r to the n. And now we can plug this thing in over here. One minus 64r over 1 minus r. Now we can solve this equation for r, and I think that's the answer to the question. I do remember that proof. I just confused to work out the actual values. 889 over 7. 1. No. 1, 2, 7. If we divide each side by 7. Now we can multiply each side by 1 minus r. Multiply the 127 inside the parentheses. Add this to the other side, subtract the 1 over. 127 minus 64. 63. Equals r. So divide each side by 63. I get 2 for r. Questions related to American schools? I guess so, yeah. I want to check this answer. The shit talking in Don's chat, you missed it. No, it is not common to get beaten by teachers in America. It would be a big scandal if that did happen. So if I'm getting 2 for R, that means my N is 5 to 6? Oh, might be 7. Wait, I'm going off on the right-hand side. 64 equals 2 to the n minus 1 is the same as 128 equals 2 to the n. 128 is 2 to the 7, I think? To 6? I guess... We'll try it both ways. $8.89. Okay, Bob, you were right. Why doesn't... What is 2 to the 6 is 64, is it not? That makes no sense to me. Why? Oh, because it's 7 terms? So n should only be 6. Okay, I guess that's why. Okay, yeah. Yeah, it just means that shouldn't be happening. That's not cool. You already changed your Discord picture, Bob? You were quick. Get charged with fines? No. If you get in trouble, you're not usually charged money. You might get suspended or expelled, as in like kicked out, but I don't think you really get fined. No. Uniforms? Not usually. Only for private schools not run by the state. There's normally certain things you can't wear, but not an actual uniform, no. Yeah, a dress code. Pretty much every school will have that, but it's not an actual uniform. It's just I don't know. They had rules like girls had to wear a certain like width of like shoulder straps. They wore a tank top or like you can't wear things that would like imply that you're in a gang, I think, were like the restrictions. Geez, yeah, twist memes. I don't know what to say though. I'm sorry that that's happening. It isn't cool. screenshot of this equation here so I can have it to the side as I look at the problem. Phones, they're becoming banned. That's like a movement that's happening in America right now. If you have it out in class, it's definitely getting taken away, or you're told to put it away. In some schools, you just have to leave it in your locker. I think some schools you can't bring it to campus at all. It depends on where you are in America for that. So this is really just plugging into a formula. They make us hunt around for all the different values that we need. But it does just come down to plugging into a formula. I'm going to assume... I thought inverse ohm meters were the exact same thing as the second, but not that there was a ratio. I guess I don't remember this chapter that well, apparently. Either way, I guess I'm going to assume we want the inverse second. 3.6 times 10 to the 4 is equal to oh, you should change your password. That's really bad. Did already? Okay. That's good. Where the heck what's the value of E? In ESU, that's not E. Ugh, they're gonna make me look in chapter 1. I want the value of E in coulombs. There we go, that's all I wanted. Because we need this thing squared. 1.6 times 10 to the minus 19. Yeah, twist means they're starting to ban phones from schools. It depends which state you're in, and even what part of the state that you're in for what banning it means, but they're starting to restrict phones more and more. A ban doesn't have to be not allowed at campus at all. It could be just you have to keep it in your locker or something. Haircuts? I don't think they restrict haircuts at all. I don't remember them doing at least. What is... We need the mass of the positive charge carriers and the mass of the negative charge carriers. Is the mass going to be... Oh, it's total mass. Isn't it? It's not just a mass per unit. Yeah, twist beams. That sounds pretty terrible. Getting forced to go to the barber. What are you supposed to use for M? M plus and M minus. What is that number in there? Is that the mass of an electron? It's a pretty small number. That is the mass of an electron. So maybe we do use that for N minus. And if it's water, do we want like hydrogen plus oxygen in kilograms? No. I guess 2 hydrogen and oxygen. Well, what's the actual positive? Is it the mass of a proton? Yeah, might just not your, like, the haircut that you want. I feel like I'm missing something obvious. Just skip That's supposed to be with the M plus that I don't quite know what to put there. The M minus, I feel pretty sure is the mass of an electron. Minus 31. All right, well, see you, twist memes. I think it's supposed to be the mass of the ion, but we don't know what the ion is, so I'm just gonna say the mass of a proton. I think. Like, I don't really know what else to put there. 1.7 times 10 to the minus 27. No, solve for x, Wolfram. There we go. 2.1 times 10 to the minus 8 seconds, which I think is a lot shorter than the mean free times. That's some of the examples we're giving in the book. Which I think makes sense because we don't expect it to go for very long before it hits something, right? Oh, that 10 to the minus 8, 10 to the minus 14, never mind. Wait, so this is even longer, what I'm getting. If I even did this right. No, it's even, yeah, it is longer. By 6 orders of magnitude? That seems weird. Wait, this is for, what is it for? The conductivity of sodium. Maybe sodium's a good conductor? Maybe I shouldn't read too much into that part. Mean thermal speed for water is 500 meters per second. So if we take the number that we get, multiply by 500, we can get the distance that it travels in the mean free time. 2.1 times 10 to the minus 8. So it would travel, by my calculation, a pretty long distance on the atomic scale. Like, isn't that stupidly long? I feel like I need to see if I can find the answer to this one. Numerated paywalls, right? They do. No. I'm not seeing, okay. Well, oh well, I guess I don't get to know. The crappy part is that all of these exercises don't have answers provided, so just kind of winging it on whether I get it right. Hmm. I guess we're gonna keep on going with more E&M. But I don't know, man. These exercises are getting a little bit lame the more that I look at them. Where do they leave off on if you see masochism? Ugh. It's true though. Last night I read either up to. Oh, this is another crazy thing where, like, okay, I started the stream talking about some of the crazy stuff that happens with relativity because this book is getting into it. If you have a box that's like hooked onto a spring, like, you know, it's hanging by that spring, the spring can measure the weight. And inside that box, you just have like this like rod that you can spin around. It has a mass on either end. Each have just a positive Q charge. You measure the mass of that box while it's at rest, and then you start spinning the rod and measure the mass of the box again. It's less than it was before, and that's just wild. The charge is the same, but the mass is less. And like, I don't know, man. It's weird. More? Is it? It's being divided by. Is this more or less than one? Maybe I'm missing. I thought they said it was less. I might be misremembering. Oh wait, I guess it is a number less than one, isn't it? I guess it is more. Because v squared is less than c. Thank you for the correction, Fizzbuzz. For me, I thought they said it was more, but I must be misremembering. Chapter 5 is pretty... It's pretty cool. I feel like I'm really going to lose the thread with them talking about relativity, but it's also kind of cool. He was worried. So other stuff with binding energy is hard to get straight too. Oh, okay. So yeah, like I never taken any class in relativity or anything like that, or I know nothing about relativity, but this book is just starting to use it to explain why the magnetic force must exist. So I've been learning it for the first time just with their little summary of relativity, so I'm sure I'm going to say something wrong. In for a time? Yeah. um... So I'm mostly hoping that like the relativity stuff is just explaining the why, but actually using magnetism. We're not gonna. Actually, I should look at the problems. Do they ask us stuff about relativity here? I'm hoping they just use it to arrive at the formulas, and once we know the formulas, we're not gonna need it anymore. Otherwise, I'm gonna really suffer more than I have been. That seems like it might have something to do with relativity, but I can't quite tell. In the rest frame? Oh god, okay. Well, okay, they're definitely going to ask about relativity then. Relativistic velocity, oh god, okay. There's only 9 total problems. Social relativity by AP French. Ooh, let me write that down. I have a little text document of books that I'm like interested in one day looking at. Where is it? Textbooks of interest.txt. Special relativity by AP French. There we go. How many questions are there total? 31. What's happening here? This feels like some symbol you'd see in Outer Wilds. In figure 5.28, it's a 1-star question. You see an electron at time t equals 0 and the associated electric field at that instant. Distance in centimeters are given in the diagram. Describe what has been going on. So I assume the electron was moving. You have to figure out what path and at what speed this thing was moving at to make a field like this. That's a pretty crazy field. Looks like a cool question though. Okay, but when I was reading this last night, I just ended here. And we were talking about how Gauss's law still holds for charges in motion. And how it's relativistically invariant charges. But it seems like the field does not have to be invariant. All right, so that's what we're about to get into. If the charge is to be invariant, the electric field E has to transform in a particular way. Transforming E means answering questions like this. An observer in a certain initial frame F measures an electric field E as so and so many volts per meter. At a given point in space and time, a field will be measured at the same space-time point by an observer in a different initial frame F prime. For a certain class of fields, we can measure this question by applying Gauss's law to some simple systems. Okay? There's been a couple times in this book where like they have so many figures that like the reference to a figure is like a couple of pages ahead. Like figure 5.4, their actual reference to it is way up here, like 2 pages earlier. Hey, Punching. Can you help me understand revolution volumes disk and washer method? Yeah, sure. I'm going to show you my favorite site for everything calculus, which is Paul's Online Notes. He does it in Calc 1, I think. Yes. Okay. So that's volume for rings and washers. And then if you just hit next section from there, it'll be for disks. And I'll actually go and explain this here too. So it's getting to the same volume in a different way. And sometimes one way is much easier than the other. In fact, often one is, I think. Well, so sometimes they're both pretty easy, but sometimes only one method is really practical. So I'm going to start by explaining rings, which I know you guys spelled washers, but washers is just like, it's basically doing two separate ring problems, which I'll explain a little bit more. So take any generic function you want, and if you want to get the volume of the solid generated from x equals a to x equals b, what you do is you imagine the function as basically the outer boundary of a ring. So I'll just take it at like some arbitrary point on the function there. I drew it very poorly, but I should draw at least a little bit more symmetric, right? And all this is it's really just a circle centered on the x-axis. So the radius is just the height of the function, whatever the function value is at that point. And we already know that the area of a circle is pi r squared, and here the radius r is just the value of the function. And thanks to the magic of calculus, if we want to take all of these areas and add them up, and like, you know, all these infinitely thin rings and add them all up, integration is the exact way that we can do that. So what we would do is we'd say that the volume of this thing is equal to the integral from a to b, and then we're integrating our area. So pi times, that's not quite right, pi times f of x squared dx. So we're integrating area and getting a volume. And that's all that's really happening with rings. So we're taking all these circles and we're stacking them up from A to B. And that connects very neatly with washers, because all washers does is it takes two rings and subtracts them. So with washers, the task is usually to find the area between two curves. So let's have a curve like that, like we just had. And then a second curve. I go something like that. Why not? All we're doing for washers is we're doing rings for the lower function. And then at the same spot, we do a ring for the higher function. This is going to be way too big for me to want to actually draw, but and we're taking the bigger one and subtracting the smaller one. And so that's how you get the area just in between the two. So the area here is pi times, let's call that f of x and call this g of x. We take our upper function, square it, and subtract it from the lower function. And square it. So that's why I'm saying that wash is really just two rings where you're doing the outer minus the inner, but it's the same exact construction there. Thanks for the follow. The book problem you're struggling with is y equals x squared, x equals y squared, about y equals 1. Okay, so yeah, we can work that out. Are you supposed to use a particular method there, or are you allowed to do whatever? I assume it's going to be a washer's one. Let me erase this so we have some room. Figured it out yourself? Okay. Y squared equals x, about y equals 1. Okay. So first off, we want to figure out where these two things intersect. The intersection points are super important because that's going to determine kind of like the limits for our integral. So if we know y equals x squared, let's plug x squared into the, wait. Does that make sense? I should do, why is that weird? If y equals x squared, we should be able to plug it in here. So x squared squared equals x squared. That's, or sorry, equals just x. Why does that not make sense? I guess it does make sense. X to the fourth equals x. So x to the fourth minus x equals 0. Factor out the x, we get x times x cubed minus 1 equals 0. So x equals 0 and 1. That's where they intersect. I was getting weirded out because we had a power to the 4, but it's okay. Tweeting the first 3 replies, no matter what they are, then your friend said some weird stuff as predicted. You then deleted, but now before screenshotting theirs. Nicely done, syntax. Let's put in terms of x. Yes, we do want in terms of x because we're going to be rotating around. Well, so I'm thinking that we're going to need to use rings here, and we're going to need to rotate about y equals 1. So because of those two things, we're going to want everything in terms of x. Say so y, okay, so y equals x squared. Looks like that. X equals y squared looks like that. And then y equals 1 is right there. So the area that we're interested in from the picture is this, and we're rotating it about y equals 1. So that's the washer that we're going to end up with. Can't read what's saying on the board. Volumes of solid generated by. Sorry, my handwriting sucks. That's supposed to be generated. Okay, so the music stopped. I was wondering why it felt quiet. Doing the problems, try and understand them. Okay, that's a great thing to do. Let me just keep the music going again. What? Okay. All right, so I was just working on my head how it's going to look. So now the question to ask is, what's our, like, washers make sense here because we're doing between two surfaces, and that usually means washers to my memory. The question we have to answer now is, what's our outer function, what's our inner function? So we're not rotating about the x-axis, we're rotating about y equals 1. So the thing that's farther away from y equals 1 is y equals x squared on the bottom here. So I'm going to call that our outer function because it's farther away. The inner function, let's call x equals y squared. And like you pointed out, we're going to want to do everything with respect to x here. So if we square root each side, we do get a plus or minus square root of x, but we can see visually we just want the upper half. So we can take the positive square root. So for the sake of this problem, we can consider this the same as y equals square root x. So now what we're going to do is say that the volume is equal to pi times the integral. The first intersection point is at x equals 0. The second intersection point is at x equals 1. Now we have the outer radius squared. The radius here, it's not quite as simple as just x squared. The radius goes from x squared up to 1. And kind of the trick that you can just always do here is you take 1 and you subtract x squared, and that's your radius. Because if I boil it down to just this part of the parabola, 1 minus x squared corresponds with that area inside here, and that's the exact area that we want to rotate around. And then in the second part, we're going to subtract out like the little bit that's going to be in there from the other part. Is the idea. You getting it now? Okay, perfect. So that's the outer. Now let's subtract the inner. So for the inner, we have the exact same thing here. We're going to want to do 1 minus the inner function. And this trick you can pretty much use all the time. I don't think there's a separate case where like you would want to do something else that I can recall. It's been a little bit since I've done these problems, but just anything you're rotating about and subtracting out the function, I think pretty much always works. And so now from here, it's just an integration problem. So I'm happy to go through and do this integration, but if all you want to see is the setup, then let me know. Setup is fine? Okay, sounds good. 1 minus x squared, why not x squared minus 1? Seems like that'd be how you shift Uh, we're squaring it anyway, syntax, so I bet it doesn't matter. I like the 1 minus x squared just because of that little visual interpretation that I drew at the bottom part. Your way should be equivalent to... Oh yeah, so what you're doing there, syntax, is you're taking the entire problem and shifting everything down by 1, which is what you said. Okay, yeah. That's completely valid too, syntax. They should both get you the same result. So yeah, you could think about just shifting every function down by 1 and then rotating around the x-axis. But this way that I normally see it taught, and I don't think it's so bad to understand that I would say to learn it a different way. But that interpretation is also completely fine. To me, they are instead of the R and R. Yeah. These problems are really tricky. If you have another specific one you want to see, let me know. Your professor didn't do an actual problem where it shifted. Oh yeah, the shifting is where it gets the trickiest. So if you have another problem you want to see, let me know, or I can talk about like just what the shells mean. So I talk about what the rings and washers means, or if you're good, then that's also good. Awesome. Thank you. And just whenever I see a new face, I like to let them know I'm not the only person who does math help on Twitch. So if I'm ever not around or you're just curious about someone else's style, there's a whole list of people. Everyone on there does math help in some way. Just a warning, some people, like me, will do some math streams, some video game streams. Some people only ever do math streams. And then some people will just play video games and switch to math if someone asks a question. So there's like a bit of a spectrum, but everyone on that list does do math help in some way. X squared and root x is like the first integral you did when you learned, because you wonder about that area in 7th grade. Like, oh, really? Does that come out to be anything meaningful? I bet it's one of those things where you get some kind of a significant looking number. It's called a leaf? Hey, Zach. Oh yeah, see, so Zach right there, e to the 2i pi is one of the other people who do math help. It's minus a third? That's kind of crazy. Oh, I switched it, but still, being a third is kind of wild. Yeah, root x is the upper one. I got it mixed up there. We really I really just drew on the board too, and I forgot. Wait. Oh no. Okay. I almost freaked out and thought that I got the outer and inner switched, but no, we were thinking about y equals 1, so we do switch them. 7 small squids swiftly swim in synchronized circles, sending 7 slimy sparks, splashing salt water softly. If every squid sends 7 slimy sparks per second while swimming, how many slimy sparks are sent after 7 minutes of synchronized squids swimming swiftly? Oh my god. What is a slimy spark? Sounds gross. I don't want to be zapped with a slimy spark. Is this from somewhere, or is that a Dr. Cook original certified alliteration question? I sure I could time travel to my younger self, whisper a third to my ears. I thought about the first. So, you know, I feel like you could just lie about it and say that you heard a whisper saying a third. And get people to believe you. Start some kind of like math cult. Dr. Cook certified? Oh, wow. Pythagoras? Yeah, he had a math cult. When one of his like followers said that, or you know, pointed out that the Pythagorean theorem implies, or you know, seems to imply that irrational numbers exist. That dude got thrown off the boat. The person who suggested that. You enjoyed it? That's just like a bludgeon. I don't know if it's actually true, but that's what I was taught. Like, you know, oh, what if we have a right triangle with both legs equal to 1? What's the square root of 2? He wasn't thrown off? Oh, okay. Could be Scientologist? That's true, yeah. What's the thing, Jed? Thrown off for sharing it with a student. Oh, I didn't hear that. Project Euler achievement get. Level 2? Only 5% of people have made it that far. Wow, that's crazy. How many do you need to get to level 2? Stats? Levels. Oh. You don't even start at level 1. You start at level 0. You're not level 1 until you solve 25 problems. 40 people have maxed out their level, wow. How many have I solved? Is this gonna... Oh. How do you see your level? Progress. That's probably a good tab. 22. I am not even level 1 then, right? No. I'm not even level 1. Dang. I've solved 2.4% of the problems. Oh. There we go. Wait. Why is it saying levels completed? I assume there'll be a check mark once I actually complete one. No 3 numbers named, when raised and neatly rearranged, can perfectly power the same past 2 as Fermat once proclaimed. Oh my god. Becomes a graphic. But you can even enter what language they're working in. Oh, it's cool. I wonder if you can get the stats for like what country is the best at Project Euler. We need another Zach data science stream. I don't know if they even like make this data easy to get though. Stokes said, with a swirl and a swoop, at the surface you sweep and the curve you loop will share the same fate as fields twist and stoop, where the curl on the sheet meets the flow around the hoop. Oh my god. Dr. Seuss, if you had a PhD in math. Cooker's dropping some math poetry. Now what does Stokes say again? I wanna, isn't it just that like a surface integral is equal to a, no, not flux. The thing. A double to a triple. Curl. I looked hard locked. I was at my board so much before too. I catches my eye, I guess, that it looks different in chat. I don't know. Thank you, though. The curl of f dot d. I need to re-look at this stuff again. Was there solving that thickness problem you were talking about? Oh, right. You're trying to find the maximum like thickness for a function you'd have without overlap. You did that? Oh, so what were you working on next then? If there is overlap, how much? Oh. Why consult a tired tone when the information you seek lies in a Dr. Cook poem? That's true. I mean, I was just trying to match your words to the actual formula. Because I've read about Stokes a few times, but I've hardly like worked with it, so it hasn't really like stuck in my head what it's actually doing. I mean, syntax. Do you get a formula for the each of like the outer boundaries? I forget. It won't be a function because there's overlap. None of it is rigorous, but it was fun to come up with. Yeah, it's an interesting like question. Like you put like being able to figure out like paving a road was a cool connection. Woohoo! Hey, how are you? Parameterized coordinates. That would do the trick. And it's possible to find the area inside of a loop of a parameterized curve, right? It should be. I'm doing good too. I'm trying to set up a little Stardew Valley session with No Cow. So hopefully next week we're able to. I'm not sure yet, but No Cow just said hi like last week, I think. So hopefully we can actually make it happen. Malik over on YouTube says, hey, Malik, by the way, how can I prove that arc cosine plus arcsine of x is equal to pi over 2? Ooh, I feel like I've seen this problem before. There should be. Oh man, I know I've done this problem before. I'm trying to remember how though. I can always Google. I want to see if I can figure it out though again. Okay, fine. Arc sine of x plus arc cosine of x. just draw a triangle. Oh, haha. I see. That makes perfect sense. It feels like a similar thing that I'm just seeing on your stream, Obi. With how you were, does that count as like deriving the various trig formulas, or as like showing how, like where they come from and why they're called that? All right, so Malik. What we do here is draw a right triangle. You do trig. And we're gonna call, okay, what we have is arcsine of x plus arc cosine of x is equal to pi over 2. So what we're plugging into each of these is, if we know sine of an angle x is, theta is a better word. Sine of an angle that I'll call theta is opposite over hypotenuse. Then if we take arcsine of each side, the angle theta is equal to arcsine of opposite over hypotenuse. And I'm saying this because in this situation we have arcsine of x, so we know that x is opposite over hypotenuse. Of course, x is, it's not a fraction, but we can also write x as x over 1 and say that 1 is the opposite, sorry, x is the opposite, 1 is the hypotenuse. So if we call this our angle theta, that means opposite is x, hypotenuse is 1. What do we do with the arc cosine? Do we want to do it on the same triangle? I can see, like, I feel like intuitively I have an idea of how this is supposed to work, but thinking about arc cosine x in relation to theta. I mean, that's what I want to, like. Do we also use the identity that sine of theta is equal to cosine of pi over 2 minus theta? I think that's an identity. Let me check it. The unmarked angle is arc cosine. The marked angle is arcsine. Okay, that's what I want to do, but I'm trying to justify why the other. I'm trying to justify why that's arc cosine. I know it should be arc cosine, that one up there. I'm trying to remember, like. And I know it's because, like, sine and cosine are really the same thing. You just swap what the angles are. But I'm trying to, like, blend that together in an actual, like, justification, like, with math symbol, I guess. Hey, Suna. I am well. Thanks for the lurk. Pi over 2 minus theta. Oh, there we go. Okay. Okay, so I may be going a little bit overboard here, but if this angle is theta, this angle is 90 degrees, and the angles in a triangle have to add up to 180, or also pi. You know that pi is equal to theta plus pi over 2 plus whatever that angle is there. Just gonna call it y. It's a stupid term, but who cares? Because I'm going to switch out in a second anyway. I can subtract these two things over and find that the angle y is pi over 2 theta. And well, this can actually stay, I guess. I don't need that. And I think all that we need to know now is that arc sine of x is this angle, and arc cosine of x is this angle. So arc sine of x plus arc cosine of x is equal to theta plus pi over 2 minus theta. The thetas cancel and we get just pi over 2. I think that's how you do it. Okay, yeah, and the only thing I want to add here, because I'm thinking about it still, is that by the same argument we made here about why that's x and that's 1 from the arcsine, we know that arc cosine of x implies that x is adjacent over hypotenuse. And so in order for arc cosine to have x inside it, it must refer to this angle here because x is adjacent to this angle. And then the hypotenuse is always the hypotenuse. And that's the piece that I wanted to justify that. No worries, Malik. Thank you for the question. While arcsine x sends sine on its way to an angle that matches come what may, but here's the trick. Together they're tied, two halves of one right angle wide. Yeah, I mean, I assumed you were making stuff off your head, but that ChatGPT question is a good one. Oh, friend the nerve, you think me sly that AI spins these words I try. Such bold assumptions, how you wound, to think my rhymes by bots are tuned. You're either incredible at poetry, ChatGPT helps, no big surprise. Yet still I craft with wit and glee, so don't discredit all of me. Cryptic replies I can get behind to messaging struggling with sign, but it's not the best way when you're trolling with glee to rely too heavily on ChatGPT. I swear, I want to pass me do this. So I remember specifically putting it in the title of one of my YouTube like VODs. Can I easily nope, that's the wrong tab. Aha! I can't hide from me for forever. This was a busy day. Holy crap. Look at all the stuff I was up to. Oh, it's because I was hopping around the math Discord. Needs chat. Since you've guessed, I must confess ChatGPT aids how acquiesce, but still my heart is in each line. Give me some credit. This art's partly mine. Oh yeah, this one gives you like a hint for how you can do it. Hey, Country Tyler. I don't know. Oh no, why? Oh dude, this is terrible. Why did I let my stream look like this? I shouldn't go back through my old VODs. This looks terrible. Oh my, I can't believe this is how my stream would look. It still doesn't look that good, but this is even worse. But yeah, welcome in, Country Tyler. I've been doing this for maybe like a little over a year and a half, like a year and 9 months. There's people who've been doing it for like 3 or 4 years though, I think. It's very niche though. What am I doing here? Arcsine of x is equal to something. Cosine of y is equal to x. Prove it, showing it holds at x equals 0, differentiating with respect to x. I guess if you did differentiate each side, you would get 0 equals 0. It's been 84 years. Yeah, like, and Simplex Pachinko there has been doing it for, I don't know how long, but a pretty long time. Okay, why my math gets less views in America? I don't even know my demographics on Twitch. On YouTube, America's the second biggest. India's the first by a lot. I just agree it's the time of day that I stream. I think on Twitch, I think America's the biggest, but then there's like a smattering of European countries that are in second or right below. Just 7 years ago, math wasn't still as fair enough. I assume I guess it's too late now, but I'm not the only one who's doing math help. Let me link the list of math streamers that I can like recommend in case you ever like I guess know someone might be in need of help. So Shay Wallace, see the views. Oh yeah, I dual stream to Twitch and YouTube, and on YouTube, people are always asking about JE Advanced. I hardly know how to do those questions though. It's 4:30 a.m. Yeah, it's crazy. There's my stream is at a terrible time in India, yet people are still like for the stream. Makes sense. You show arcsin x plus arcsin x is constant, then you show what branch it's on. J wall the company. Oh, interesting. Cosine of y equals x if I take the cosine of each side. So arcsine of x is equal to arcsine of cosine of y. And then we are adding these two equations together to get y plus arcsine of cosine y. And then we can draw a right triangle. I assume to get... Oops. What did I do? I don't know. The cancellation, no, like the same type of cancellation. Why am I getting confused on this? And then I just go to a different question. Probably someone beat me to it. Okay. I actually kind of like this argument. It's maybe a little bit more complicated than you need, but that's the type of argument that I was looking for. It went from a YouTube channel to $1 billion business. Wow. Yeah, like that's a simple way of just looking at it with the picture of the right triangle. For whatever reason, it just doesn't feel that natural to me, but it is the easiest one. Your teacher is undoubtedly Sheesh Agarwal Maths. I'm probably pronouncing that wrong. Interesting, slow turtle. I probably am not going to stream for a ton longer, but I'll give it a little more time to see if someone comes in and asks a question. Do I know what a one-shot is? No. I only know of a one-shot in like a video game. Your squid question? That's true, Cook. Type shit 90. Thank you for the follow. Wait, is that type shit or types hit? I'm surprised that Twitch allows shit in usernames. I don't think I've seen a username with a curse word in it before. Either way, welcome in. Country Tech as well. Thank you for the follow. Some of that new math. I've never seen this before. Oh, I didn't. Oh shoot, I don't know what exactly math or what like screen I had up when you said that. This that I have up on the screen right now is physics, electricity, magnetism, and this chapter is a little crazy. You're Malik from YouTube. Oh, nice. Welcome in. Since you are on Twitch too, let me link you. There's a bunch of other math help streamers out there who do math help as well. Everyone in that list does. You're seeing the math as well. Oh, okay, fair. All right. Let's look at Dr. Cook's squid question. 7 small squids swiftly swim in synchronized circles, sending 7 slimy sparks, splashing salt water softly. If every squid sends 7 slimy sparks per second while swimming, how many slimy sparks are sent after 7 minutes of synchronized squids? Well, we have 7 squids. Each of them are doing 7 sparks per second. So in total, we're doing 49 sparks per second. And we have to convert 49 sparks per second to minutes. So we multiply by 60. And then we multiply by 7 for 7 minutes. 20,580 slimy sparks per second. One shot is basically covering every topic of subject completely in like under 10 hours. That's pretty ambitious. Setting slimy sparks, apparently. So I've been doing a reading group for electricity and magnetism out of this textbook here. A lot of slime and a lot of sparks. So we're doing an actual like electricity and masochism. So we've been reading this textbook here. On each Saturday, we have an actual like meeting on this. We're currently on chapter 5, which is just introducing magnetism. And it explains it using special relativity, which I've never studied in my life. So it's kind of crazy what relativity does, but hopefully I can. Like the book's been insanely difficult, but this is like this is like a different level. Salim Sir one shot. Okay, good to know. You love relativity. I mean, I'm getting. Okay, you talk about relativity and then also seeing the little bit that this book is doing relativity. It's kind of cool. Like the mass of this box changes. It increases just by having that rod spinning around and being in motion. Physics Galaxy Electromagnetism PDF. Oh, okay. How long is this chapter? 5.5 starts on 243. Oh, okay. Oh god, 5.9 goes on like 20 or 30 pages. More like 20. Did I do my math wrong? I thought this was like less than 30 in total. Oh well. I said it was a short chapter in terms of reading. It might not actually be that short. It's meal in Hindi. Oh god, I can't even learn Spanish. Much as a language that's not even like slightly related. It's a book called DC Pandy. Oh, okay. Read more in dynamics text with the red cover. Is that the one that I saw being thrown around for Penn Center's physics stuff? Oh, okay. Is it easy? Is it at the same level as this book? In terms of difficulty? Resnick held it. I think Thinbox is looking at that book. I'm really studying out of this one book. I think it's gonna be hard, yes? Oh, good. We need to really put Penn Center through the physics grinder. You think lectures are so much better? I mean, yeah, a lot of stuff, a lot of E&M stuff would be way easier to understand with like an actual professor to like guide me through it. So, Dr. Cook has been like pretty kind and like helping out with a lot of stuff. But yeah, there's some of the concepts that only going off this book are pretty freaking hard to understand what's actually happening. But I don't know. It's the price of just like self-studying. Presence of multiple real life Sheldon Coopers. This is sick. Yeah, there's a lot of nerds around here, myself included. I do also like to play games and just like chill out, but I don't know. This is helping people out with math is something that I like to think that I'm good at. And it just seems like a cool idea for a stream. It's still a little bit. This whole like math thing on Twitch is still like kind of too niche to really work as well as I would like it to. But it's slowly growing. Yeah, that's crazy quick, Slow Turtle. Great YouTube vids for relativity. Tight, 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 tight. That's from Breaking Bad, isn't it? Like Tuco or someone does like okay, I'm gonna make myself sound stupid. Were they snorting meth? Is that what was happening? I forget. I don't think I've ever heard of snorting meth, but like they're crushing something up and snorting it. I just remember him like doing that. Tight, 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 tight. Tuco, yeah. Okay, you do snort meth. That's what I remember happening, but and Chris does the same. Okay, it's good to know. Breaking Abbey was a great. I haven't seen it. Just cast a break mid to do a crossover joke. Oh, nice. Reference user cards in those videos might check them out. In this one? Or in this one? I don't know. Maybe something else entirely. This cast is Downton Abbey. Oh, okay. In the thumbnails? Okay. Oh, yeah. There's a car. All right. I mean, honest, usually when I'm off stream, I'm kind of too tired to, like, look at stuff like this, but if I do have the energy, I'll give them a watch. Yeah. I'm sure there wasn't anything that was like pinning my Discord, right? No, I think we're good. Okay, so turtle. I'll look at it more later. Hmm. Chinese YouTube quantum field theory lectures from IIT Madras. The lecture's pretty good, I'd say. Ooh, okay. Inertial frame F measures the electric field E. So and so many volts per meter at a given space and time. Oh, I've never cared about Olympiads personally. Not even an age thing. Well, to be fair, I guess I didn't find out about them until like I started streaming on Twitch, but like I think even as a kid I wouldn't have been interested. What's that, slow turtle? Why do I have to guess? I don't know. $100,000, sure. Because I really have no clue what it's supposed to be. Like, what's even a reasonable guess? General relativity. Oh, nice. Okay, so our familiar parallel plates example. The inertial frame F prime moves towards the left with respect to F with velocity v. X prime dimension is contracted from b to b root 1 minus beta squared. Close to 1,000,000. Oh, wow. Holy crap. In 10 books. And that's the same person. Okay. Dang. Oh, wow, slow turtle. Your problem's down. You're safely in the top 5% now. Nice. Top 5% Project Euler solver. That is kind of weird, Cook, yeah. Um, it's a lot harder from here on out. Like, have you already gone through, like, all of the early ones? All the other ones are pretty low percent. Hmm. I don't know. I think we might wrap it up here because I'm getting super hungry all of a sudden. We haven't a math question in a while, so. Let's do organic chemistry. Ooh, good luck. You'll DM me? Okay. Some food? Yeah. Let me see if there's any like friends of the stream around. There's this person potentially say hi to. Is anyone actually doing math though? Maybe we'll take a look at science and technology category. Oh yeah, thank you, Hoo Hoo. Thanks for being here. Okay. I'm not seeing in particular who's yeah, I saw science streaming, but I don't know, I don't like rating into big channels. I feel bad. Let's cut the YouTube stream off here. Don't do that. I'll try not to cook the shit out of it.